Okay. Hello, everyone. Welcome to today's NetData webinar. I'm just going to wait another minute so that anybody who is joining can join. We have a lot of people who have signed up for today's webinar and hope everybody gets their time's worth. So while we're waiting for people to join in, I can give a quick, brief introduction to start things off. I'm Sham. I head product and strategy at Netdata. And today we have with us Juan, who is the lead developer for all of Netdata AI features. So if you have any questions about Netdata's MCP or anything else Netdata AI related, you have the right guy on the call. So please send in your questions. Welcome, Juan.
Thank you.
I think yeah, we can get started. Let me just share my screen. So today's session, like I mentioned, is going to be about Netdata Cloud MCP server, which we have released a few days ago. This is mostly going to be a hands-on session. So we will briefly touch upon, what is MCP, what is the MCP protocol, how Netdata has architected our MCP server, and then we'll jump into the live demo. Most of the time on this webinar will be on the live demo, as most of you like it, and then we'll have hopefully have some time for Q&A towards the end. So I'll keep this quick. Before we get started, I just want everybody to understand, in case there are people here who have not heard about or have not used any MCP servers previously. MCP stands for Model Context Protocol. It's an open protocol. It's an open standard that allows AI assistance, basically any AI client. It could be ChatGPT or a Gemini or Claude or any of the tools that you use to connect to external tools and data sources. And now these could be any kind of application. Netdata is one of them. It could be GitHub, it could be Slack, it could be PagerDuty, it could be anything. So instead of having to manually copy the context from these other tools and send it to your AI client, you can connect it via the model context protocol so that these two different things can talk to each other. The AI client is able to talk to your applications, your tools, and ask for data. And also, it's a bi-directional connection. So it goes both ways. So this is what the MCP is. It was originally created by Anthropic, but it's widely adopted now. So almost every AI client out there, including Claude Code, Codex, ChatGPT, but also Cursor and VS Code, and all of the tools that you would be using to interact with AI models, almost all of them support MCP mechanism to connect to servers, MCP servers. And since it's taken off, most applications out there are also building their own MCP servers, making it available. So having the ability to interact with multiple different MCP servers is kind of like a superpower, right? So in the diagram that's shown here, you can see that using your AI client, you should be able to interact with Netdata, but for metrics, logs, anomalies, etc. But at the same time, interact with GitHub or PagerDuty for other kinds of information, like code or messages, alerts, etc. So the ability to do all of this together along with your AI assistant or your AI agent makes it a lot more powerful than just using it plain vanilla. So this is the idea behind MCP. And we are specifically going to be dealing with Netdata's Cloud MCP. We also have a Netdata Agent MCP server, which was released in version 2.6. It's been out for a while. And each Netdata agent has an MCP server that you can access at port 19999/MCP, specifically for direct local access to what's available on that specific node. The advantage of using Netdata Cloud MCP is that you can have full visibility across your entire infrastructure, all of your nodes. uh, you it's really easy to set up. You have access to all of the tools that Netdata Cloud brings, um, including the features that we use internally for our Netdata AI capabilities. And you can now use it with whatever other AI tool that you use. So there's a lot of things that you can do with it. This is just a quick snapshot. We'll talk more about it as part of the demo. But I also wanted to touch a little bit before we jump into the demo about what our overall plan is for Netdata AI. Um, we like to build in the open as far as possible. So we want to support MCP servers on our agent as well as on the cloud. But also what we plan going forward is to have, let's say, the ability to also operate as an MCP client, so that Netdata Cloud and Netdata AI can not just talk to your LLM clients, but also to other applications within your ecosystem. So if Netdata AI is troubleshooting an incident or an outage, it should have access to more than the metrics and the logs or the traces and information that's observability level, but also information that's additional context about what's going on. So, was there a deployment that happened recently? Were there messages in the team Slack about possible issues? Is there information in PagerDuty, in GitHub, in Jira, in all of these different places about what's going on right now, what's happened in the past, is it related? So all of this is context that all of the human teammates already have, and we are carrying it around with us. But when we try to assign these tasks to an AI agent, it doesn't have any of this context. So today already you can try and manually pull in all of this context and feed it to the model, and it does great. But this manual task of collecting context is not an easy one, and it's also not straightforward how much context is enough. So we're trying to build that internet data AI so that it happens automatically. This is one of the early steps, having NetData Cloud operate as the MCP server, and soon we'll see the subsequent steps as well. But this was the initial intro. I think we're good to jump into the live demo. So I'm going to stop sharing right now. And Juan, whenever you're ready.
Okay, thank you, Sham. Let me share my screen. Okay. Um, okay, so in this session, what we are going to do is basically show some scenarios that we can find ourselves in when we are troubleshooting incidents, etc., and how to use MCP, Netdata Cloud MCP, in order to basically move faster from, let's say, some symptoms to evidence, right? So for this, I have prepared this space. It's a Netdata Cloud space that contains some nodes. We have a Kubernetes cluster here with, as you can see, some worker nodes. We have some another node for the control plane, etc. These nodes are organized in different rooms. They are placed them there dynamically because I have some rules set, etc. And these nodes are collecting currently, well, as you may see here, we have different metrics, all the net data metrics that we support usually. Also, as you may know, we have released in the past few weeks support for OpenTelemetry. I have configured these clusters in order to receive OpenTelemetry metrics. So you can see here that OpenTelemetry metrics are collected from different services that are running in the cluster. We see in this right side the application, different application containers, different application pods, also from different technologies. We have Golang pods, we have HTTP
Just a
servers.
just a comment, Juan. Can you zoom in a little bit? There's a comment that the screen is not visible.
Okay, sorry.
Yeah, that should be enough.
Oops, too much. Okay. Yeah, so as I was mentioning, these are different OpenTelemetry metrics that the Netdata application is collecting in the cluster. Also, we have released as well support for OpenTelemetry logs that we are also collecting. So in the parent, I have configured the parent to receive directly from the Optel collector. So you can see here that logs are being received in real time, right? The logs that currently are being shown are from an application that I have installed for this demo. This application is an OpenTelemetry official app that for this kind of demo purposes. And basically what we're going to simulate is an e-commerce site where you can buy different astronomy items. For example, you can buy telescopes, different kind of them. You can buy binoculars, flashlights, etc. So this is a totally functional site for our use cases. So we can add them items to carts. For example, let's add a few of them. Okay, we are ready to place our order. Yeah, okay. So the idea is that I have in the cluster and pod that is generating load. So that's why we see all these logs being generated automatically, right? You can see here the pods that are running in this demo site. All of these belongs to the application, the astronomy side. We have the Netdata installed, all well, different pods that belong to Kubernetes, etc. Okay. Before starting showing different scenarios, first thing is to install MCP plugin in our AI clients. Okay, so in the learn page of Netdata, you can find all the information related for this. You can see basically the instruction for a lot of different clients. You have Cloud Desktop, Cloud Code, Codex, etc. So in my demo, I'm going to use Codex. Basically, I'm usually using Codex or Cloud Code, depending on the task I'm working in. And the first step before configuring one of these clients is to create a token. The way to create a token is going to your user settings in Netdata Cloud, click on API tokens, and create a new token. Okay, you can name it and use the scope MCP. This way, this token has access to the MCP plugin. So once you create it, the tokens appear here. Did you need to copy this information because this is the token that you actually need to set in your AI client? Because you also won't be able to see it again, right? So I'm going to use it, the one that I'm going to delete the one that I just created because I have already created another one that I will use during this demo. Okay, so let's start by configuring our Codex client. I will show you the configuration that you need, how it looks. So for example, Codex store the configuration usually in the codex config file. Basically, all you need, let me try to zoom it. Probably this also is better here. So basically, you need to set this block here in that file, the URL. That's also in the learn page, and you need to set in your environment a variable that is associated to the token that we have just created, right? So in this variable in the environment, I have my token, and is the token that is the variable that Codex will read in order to have access. Once you create a token, the token will have access to all the spaces that you have in Netdata Cloud. Also, depending on the permission level or the role that you have in those spaces, codecs will have the same role on them. I mean, you can be admin on some spaces, but you can also be a troubleshooter or an observer in other spaces. So depending on your role in that space, that will be the role that codecs or any other AI tool will have when accessing the information, right? Okay, so I have also prepared a dashboard that we can use in this demo to see the activity. For example, when we do some scenarios, let me put this side by side with my terminal. Okay. Okay, where's here? Sorry if this doesn't look very big, but basically I've just added some charts just to see the activity that we will be having. So for example, here I'm showing system CPU by node, system run by node, the the traffic in the network. And then I have some container metrics here. For example, you can see here the CPU by pod, the memory usage in percentage, depending on the limits in the cluster that are set, and also the memory used by each pod in raw values. As you can see, the load generator pod currently is the one that is generating and using more CPU, because this pod is basically creating different Chrome processes that are exploring the web and generating the load directly. Okay, so let's start by seeing if this works. if codecs have access to. Oh, let me move to the folder I want to. Okay. Let's see if codecs have access to our spaces. For example, let's ask simple questions like, can you tell me? Okay. So the MCP integration offers different tools that the AI client can use. When the AI client loads the integration, basically it receives a list of tools that it can use. So one of these tools is the get profile tool. That basically is the first tool that the AI client will use, because it tells the AI
I think Juan just dropped off. Let me try and get him back.
okay.
You're back, Juan.
Okay. Did I disconnect it or something?
Yeah, I think it was just a few seconds ago, so it's okay. Keep going.
Okay. So as I was saying, the first tool that usually the AI client will use is the get nodes. Basically, it returns information about all the spaces, rooms, and nodes that you have access. So in this case, we saw, okay, we asked how are the nodes in our infrastructure, and it found the information. It found the workers nodes, the control plane nodes, and also the two nodes that are created by Netdata across the cluster when it's installed in Kubernetes. So yeah, let's also, for example, start asking by the pods that are running in the system. Okay, I'm asking to tell me the pods that are currently in my system running and how they are distributed across the different nodes. Basically, I'm asking to tell me information that is here. Basically, the list of pods and the how they are distributed. Okay, let's wait a bit. Codex takes a bit analyzing and generating this. Okay. It uses the getNodes tool. This information returns information about a specific space. Oh, and it search metrics here. Here it tries to search metrics related with pod and also metrics related with Kubernetes or similar to kube, etc. It found this, the pod phase, that basically what from the ones returning, because it returned a lot of metrics that are obviously related with Kubernetes, it selected this one basically because it contains the status of pods. Then what it did is search for metadata. This tool basically returns all the labels and the most important information about our metric, about a metric. Like for example, the units, the this one, the units, the title of this metric, the context associated to it, different the retention, for example, how much data you have about that metric, different retention depending on the resolution, etc. Also, it returns all the labels. So with that, it found that it has everything needed and it requested data. As you can see here, when requesting data, use the grouping by namespace, Kubernetes namespace, Kubernetes node name, and Kubernetes pod name. Basically, it will receive a series grouped by that. So with this, it could have all the information needed in order to to answer the question that I asked. And here it is. So you can see that it found 46 running pods. As you can see, it's the same that appears here. We have 46 running containers currently. And yeah, basically the distribution per node. We have the different worker with the pods that are running, etc. Okay, so let's go with something more interesting. Let's try to simulate a scenario that an infrastructure issue that can happen frequently in this kind of setups in a Kubernetes cluster. So let me prepare this. Give me a second. Okay. By the way, if you have any question, feel free to ask them, and we can stop and answer them.
Sure. I think there was a question earlier. Let me see if I can just pull it up on the screen. So this was a question from Dan Benton, whether the MCP supports a Netdata parent configuration. I think the question was when we were talking about the MCP on the agent MCP server, whether it works for parents too, in which case the answer is yes. So if you have a parent node and you have data from multiple children within it, the MCP server should have access to all of it.
Yeah, exactly. Okay, so as you can see here, I'm simulating a scenario. Uh, any guess what can this be? So look how this node, all the pods associated to a node are down, are having issues. And you can see now that the cluster is rebalancing some pods. So what we are simulating here is a scenario where a node goes out of the cluster in Kubernetes. So let's try to ask MCP. Let's ask MCP to see if it can figure out what's going on. Okay. I have.
While Juan is pulling that up, just to add to the previous answer to Dan's question, you would still need to have that node connected to Netdata Cloud. So the MCP is something that happens locally, but the node needs to be claimed.
Okay, you can see here that, okay, this affected some containers. These containers have been placed.
I think the text is a little bit small, one, at least for me.
Let me try to. Okay. Okay. I have asked the LLM that I have seen some strange activity in my cluster. So let's see if we can figure out what's happening. Oh, look, the node inventory change. So it identified that it's affected the demo worker 3 node. Okay, it's no longer in the current Netdata node list, and the Netdata parent have new ID. So I'm checking whether this was a node replacement or disconnection. So it identifies properly that the Netdata node associated to this worker is now in unreachable state, and the components that were placed there were recreated. So it asks for different data and different metrics. So it's now trying to figure out if it was a monitoring restart versus an actual cluster outage.
While we wait for that one, I think there's another question. I'm just gonna put it on the screen. It's from 254 Willie. Will the MCP be able to analyze any high-level anomalies related to security and perhaps give mitigations?
Yeah, through MCP, for example, you have access to logs as well. So depending on the information that basically you expose to the AI client, it can understand and try to find out some root causes or find out improvements about security, etc. From the metrics alone, probably not. But if you go to if you add information in logs, probably, or even if you give access to it to different repositories, for example, where you have code, you have configuration, etc., You can combine all these tools. The good thing about MCP is that it allows you to configure as many tools as you wanted to have access to. Basically, these tools are you can configure it to access external sites, repositories, any kind of data source that you wanted to have access, and then you can trigger and can make investigations based on that information.
Yeah. So I think the answer is yes. It just needs the security related information to be available in the logs and the metrics. You might need to enable some custom collectors, enable other MCP servers maybe, but it's definitely possible. So maybe after Juan's demo is done, I'll do a small demo. We could try this out just to see what sort of answer we get without any prior setup. There's another question from Rolf. Um, does it have access to the anomaly bit time series that go with every metric?
Yes, we have different information in our metrics. So when we have like three associated time series to each metric. Is the actual value metric, then the anomaly bit metric that contains anomaly evaluation about the values of that metric at that moment. This is calculated automatically by Netdata agents. And then we have also some point annotations that basically can identify if a metric is not being collected by all the nodes that were contributing to it, or if a metric have any other issue, like for example, being null or is have a higher value in the aggregation, etc. So yes, through MCP you can find all this information, and also you can sort information using different attributes, like for example the anomalies. So you will receive metrics sorted by anomaly as well. So the AI client already finished. Basically, it says that the demo worker was affected and also showed us the pods that were running in this demo worker at that time that were affected as well. So it got the issue, and this it also says it was not a full cluster outage, and well, basically we can continue to dig into the investigation. But as if this has been a manual action, probably, I mean, it would be very difficult for the LLM to figure out that in fact it was a manual action. So let me recover so I can restart again the worker 3. So we see that everything gets back to normal. Okay, yeah, that's it. No new alert. Let's see if it finds that this was recovered. And in the meantime, I'm going to prepare the next scenario.
So while we're waiting, there are a few more questions. Some of them I'll take during my part of the demo, but there's one from Dan, which would be good if you can answer one. It seems ChatGPT requires OAuth authentication, which your MCP service doesn't support.
Yeah, exactly. Currently, we only support bearer token authentication. We are evaluating also this OAuth access, but yeah, for the moment, only clients having OAuth, only having bearer token authentication support can use our MCP server. This mostly supports all CLI clients. I mean,
I think, yeah,
Codex, Cloud
I
Code,
think that,
etc.
yeah, I also think that there are some workarounds for ChatGPT that involve having proxy servers running and stuff. It is not straightforward, but it could be achieved. Um, but yeah, we're evaluating what we can do to enable the other clients as well, more clients as much as possible.
Mhm. Yeah. Okay, so yeah, it confirmed the agent finished and confirmed that yes, the demo worker already has been fixed. Let me put this in first play because yeah, this is the metric that I was also pointing out. As you see, Netdata here detected that one of the nodes was not contributing to the metric as before, and that's why this is a pink ribbon in the chart here. So once the worker 3 recovered, this pink ribbon disappeared because all the nodes are now contributing to the system CPU metric. Okay, now let's move on to a scenario probably more business related and also that probably is facing uh, errors that are more that facing to users. So as I was mentioned before, we are using this e-commerce application. So one of the scenarios that we can find is that, for example, one of the functionalities stopped working. And in that situation, the ideal scenario is to receive an alert, but sometimes it's difficult to create alerts for all kind of errors that can appear in an application. So sometimes is we realize about this about when users report or creates a report about this. So in this case, what I'm simulating is an issue with adding elements to cart. As you can see here, I'm clicking here, but it's not working. This UI is not showing any error, but it's not working. Probably we can see the exact. You can see here. Okay, look. When I try to add a current an element to the cart, the server is returning a 500 errors. So most typically we would find this kind of issues about users reporting an issue. So we would need to investigate them. So let's try to do this with AI. Let's see what happens. So I'm telling now that users are reporting that add to cart and cart operations are failing. Let's try to ask it to find the root cause and also identify which are the affected services. This is a deeper investigation. So for that reason, it creates a plan composed of multiple tasks. We can adjust of course, we can adjust the level of investigation of this kind of clients. I have it to the highest, but that's why it will take a few more time to complete. So what we can see is that basically it starts by requesting alerts, searching metrics related with cart, and different elements, for example, bulky. It also searching for logs on the metrics on the servers. Oh, I need to ask, probably need to give it a hint because in this demo space that I created, I'm storing logs in the Netdata parent. Let me give it a hint because if not, um, you can find the logs in Netdata. This
We
is a
have
good
also
example.
added, yeah, just a
Sorry.
point while we're waiting, Juan. I just want to tell everybody that we've added a lot of optimizations into Netdata Cloud on the MCP side as well, so that, for example, when you're searching for specific kinds of logs, it does it optimally without using up all the context window or all your token budget on just sending it huge amounts of logs. So it's able to intelligently filter and find what it's looking for in an optimal fashion.
Exactly. We provide a lot of options for filtering and grouping information in order to reduce the size and also to get to the point uh, depending on the case. So the hint I had to add it here is a good example that the issue with AI clients is that they don't know exactly about your infrastructure uh, initially without you giving all these hints or guiding it too much. These clients usually support adding this kind of information in file names. For example, in Cloud MD, you can add information, or in Codex, Codex also support the agents.md file, where you can add this kind of things. For example, particularities about your system, like the logs are stored in the server, or this alert is not critical. If you see active, don't worry about it, etc. These kind of things that we as humans get used to them, and we don't. We understand that we need to filter out in investigations. For OpenAI clients, you probably need to add also this kind of instructions for them to be effective. So it's searching logs, and I see that it's starting to find some errors related with the card store. Let's see. It seems that it's finding the issue.
Just a quick time check, one. I think we're 45 minutes in. So maybe after this, we can transition to the next part of the demo and then Q&A, some time for Q&A at the end.
Yes, of course. After we finish this scenario, I think we can switch to it. I hope should be almost finished.
If you're going to be testing this out, it's also interesting to try and use it with multiple different agents. So Juan is showing us Codex right now, but you can try Cloud Code, you can try Gemini CLI or other tools. It's interesting to see which AI models are better at what kind of tasks. They all have their own preferences, or let's say expertise in certain areas, and different people like using different models. So it's it's fun to play with.
Okay, it's summarizing what it found. Okay. So here basically it says that it has found, well, if mixing things from the previous incident because we are journeying incidents too fast. But the thing is that it found that the card instance disappeared and could not reliably connect to Redis. Basically, in this scenario, we were simulating a Redis issue, so the pod could not connect to Redis in order to store the card items or to retrieve them. So it also found the affected path, for example, the front end calling this service, and then um, the Redis instance for the card having issues. Also identify the endpoint that was failing, the returns that were returned, and also the operations like add items to the card and get items from the card. So yeah, I think we got it right. So Sean, if you want, we can switch to the last
Sure.
to your last.
Thanks, Juan. It's nice that it also gave links to the evidence and the timestamps and things. So that was really nice. Thanks, Juan.
Thank you.
Let me also do like a quick uh, demo. This time, since we already covered the CLI agents, let's do it using Cloud Desktop. So this is my Cloud Desktop. I've already connected the Netdata Cloud MCP here. You can see that it's available here. And I can now ask it something like, can you check my Netdata demo space? Tell me what kind of infrastructure I have. So it works the same way as what Juan was showing from CLI, but this can run on the web, on your desktop, from any of these clients. ChatGPT unfortunately doesn't allow bearer token yet, but there are lots of other tools that do. So you can see that it's found the Netdata demo space. It's pulling in the node details. It's giving me the breakdown about what kind of nodes I have. So this is our demo space. So it's a hodgepodge of all kinds of different nodes in here. So you can see there's Linux, Kubernetes, Windows, a bunch of network devices. So you can just have a conversation with this. I'm gonna just wing it. What could I be doing better with my infra? Let's see what it says. So here's some insights that it's brought me, that our geo-distributed demo nodes are dead weight because we have a bunch of stale nodes across different locations right now. The IBM DB2 collector node is on fire. This is by design because it's a demo and we wanted it to be on fire, but yes. And network reachability from one of our nodes is broken apparently. So it's asking me if I want to trigger a deeper investigation. Instead, I can try and give the question that Willie had earlier. So give me an analysis of high-level anomalies related to security. I'll keep the typo in. Should be able to make it out. Let's see what happens. So it's looking at firewalls, Active Directory, network devices, all kinds of things to try and see if it can get any security related information in here. Ideally, we would have provided it access to certain collectors or other tools that have the security level information. We've done nothing of the sort here, so it's going to try and get to the analysis based on the data that it sees. So the newer models, like Opus 4.6, which I am testing right now, are really good when it comes to handling hallucination issues. So it's very minimal, very hard to see during daily operations. So if it doesn't have access to data, then it's usually going to tell you that it doesn't see enough data to be able to give you a proper answer. But if there is answers, if there is data, then it'll give you a really good report. The other thing to note, if this is the first time that you're running this, you will usually get these prompts to approve access or allow access to specific tools, but you only need to do it once per tool. So we have a few, more than a dozen tools. So you might have to kind of click allow uh, the first few times that you run this, but otherwise it should be pretty seamless, like you're seeing here. And you can click on this to expand and see what's happening internally. So you can see that it's called specific tools. It's looking at specific data points, and this is what's happening. So let me see while it's working if there are other questions that are related as well. So there is a question from Rafael Flores. Juan, maybe you can take this one.
From NCP, that's a good question, a great question, because I also forgot to mention that from NCP, you can trigger reports on Netdata Cloud. We have a tool available that if you ask uh, your AI client to generate a report, it will trigger it. It will communicate with them with Netdata, and the Netdata agent can generate the report in the background. And once it's generated, it can send you a notification so you can review it, and also you can share it with other members in your team, etc. So yeah, that's also possible to be done. For example, in Netdata AI, we have agents that are experts in alerts configuration. This information is not easily available, for example, for codecs to retrieve. So these agents that are placed in Netdata AI can, for example, recommend new configurations, can analyze your alerts, show you why they are, what is missing, etc. For example, in the scenario I showed before, the card error was not triggering any alert. You can ask Netdata AI to investigate which metrics and which alerts you would generate for this to be triggered in case of being repeated. And then
Yeah.
it can identify also do an analysis of the history of the metric values in order to identify which are the best thresholds for these alerts.
Yeah, so the follow-up from Rafael was also, can it warn us before an outage might occur using alerts or analyzing more in depth automatically? So to answer that, Rafael, what we're building within, so MCP is still a reactive tool. You need to connect it, you need to ask it, and it'll respond to you. What we are trying to build in Netdata is also an AI SRE agent that will run autonomously 24/7. So that is what will do this task of looking at everything and identifying if an outage might occur, and then reach out to you with either alerts or anomaly information or a report about what else is happening. We intend to design this in a way that it's going to be running 24/7 and checking if anything needs to be brought to your attention, and then it can do that, even through the tools that you already use, like Slack, for example. So we have the answer from the previous question from Willie. So it's done an analysis across the security landscape. and it's identified some critical issues here. Um, there are firewalls with issues. There's 12 nodes pending reboot. There are some high issues with SSL protocol mismatches, and then it kind of broken down into like great detail each of these specific issues that it has brought about. And you can see that it took many minutes to do this because it was a very involved query. It had to do a lot of tool calls. It hit some limits in between, but at the end it kind of plugged through, and it was able to give you something that was meaningful. You can use this for all kinds of analysis. It can even be reports that are quite let's say very explicit about what you're looking for. So I can ask something like analyze the alert patterns across the space over the past 7 days. Are there alert storms? Give me recommendations. And it's going to go and try to collect all the data and do this. Now, you can do this manually as well, but it's going to take you a long time. You can do this internally inside Netdata AI. Um, for that, you would need Netdata AI credits. So this is the tool use that it's asking me to approve. You can, if you're already using certain MCP tools, you can use it, but it does come with some limitations. You can see that it says that the tool result is too large, maximum size 1 MB being hit because I asked for 7 days of data. So there is a bit of balance in terms of what using the MCP either through a client like Claude or through Claude Code or Codex would offer you. It especially using the CLI agents, it helps you keep you in the flow while you're developing things. You can check what your deployment status is, and if you have issues there, and keep going at it. But also the ability to just do it directly from within the Netdata UI has its advantages because you have the dashboard right there. You don't generally hit issues like the one that you're seeing here with the size, context window size, or the number of tool uses that can happen. We've tried to abstract away much of that problems for you. And I think the big unlock that's coming is with the AI SRE mode, which will be running all the time. And we want to abstract away some of the complexities of having to connect a whole bunch of different kinds of tools together, so that from Netdata you would just be able to configure like a normal integration, your connection to a GitHub or to a Jira, to a PagerDuty, to Slack or MS Teams, and Netdata would then just automatically be able to fill in that context about things that are security related. Maybe you have another tool that you're using for SIEM or security, and ideally Netdata should be able to talk to that tool. That tool should be able to talk to Netdata. So this is where we think the future is headed towards, and this is where our roadmap is aligned towards, definitely. Let me see if there are any more questions. There is a question here. Are the tasks for investigations agent-based related for specified rules that governs AI to perform detailed flows while performing analysis, or is it just a singular prompt input? So I can take a stab at it, and maybe Juan, you can explain after that. So if you're using the MCP servers, it is prompt based. You ask for something, and then you get a response. The AI agent tries to reason about it. We have created a set of tools for the AI agent to use to fetch the data, to filter the data, and make the AI model better understand the data. Uh, if you're using Netdata AI directly from inside the app, then it also comes with our playbooks that are part of Netdata AI. So we have battle tested prompts that are kind of built into the product that handle some corner cases and issues and things like that. But with the direct MCP server use, you would need to kind of craft the prompts yourself. Um, but in general, the new models are very smart, and they can figure things out. So I think we're making Claude do a lot of heavy lifting. Are there any other questions while we wait? Okay, it looks like we have our analysis. So it's done an alert noise breakdown for the last 7 days. There was 2,200 alert transitions across 56 nodes. Some of them are real alerts, some of them are flapping, and you get a breakdown of which were the noisiest nodes and which were the flappiest alerts. And some of this is to be expected on a demo space where we're injecting issues into. But yeah, it would be nice if you can do this sort of analysis on demand, call up dashboards, custom views. So it's telling us that 80% of our alert volume is noise here. There is a nightly restart storm. There's load average issues. So there's a bunch of discrete issues, and then it gives me a summary, as you can see. So yes, so this is how it works. I hope everybody is excited with what they've seen, and that you'll go and try it out. If you face any issues when you do try it out, feel free to reach out to us. We'd be more than happy to help you set it up, help you get it running. Yep. And we're going to be working on adding more capabilities both to the MCP server, so more tools, and also, like I mentioned, with Netdata AI, being able to connect it to all the other tools that you already use in your team, having more capabilities added into Netdata AI. This is what Juan and I and a bunch of other people at Netdata are focused on. So that's what we're going to do. If there are no more questions, we're just going to wait a few more seconds, and if not, uh, thank you all for sticking around with us. So I think there are no more questions. Thank you so much for your time, Juan, for joining.
Thank
Thank
you.
you, everyone, for your time. I know we ran over by a few minutes. I hope it was worth it. Um, yeah, thanks, everyone. Have a good day. Have a good rest of the week. Bye.
Thank you, everyone. Bye. See you.